Universitas Airlangga was established. Universitas Airlangga is the second oldest university in Indonesia. Since it was established in 1913, Universitas Airlangga has become the best university in the eastern part of Indonesia, proven by the students' various achievements, both in academic and non-academic field. Universitas Airlangga has expanded to 14 faculties, which located in its three main campuses, Campus A, B, and C. One of the faculties is Faculty of Science and Technology, located in Campus C.
Welcome to Faculty of Science and Technology.
Faculty of Science and Technology is an expansion of Faculty of Mathematics and Science Universitas Airlangga, which established since 1982, and in April 10, 2008, it officially became Faculty of Science and Technology. FST has 4 departments, and each of them administers several study programs. Mathematics Department administers Mathematics, Information System and Statistics. Physics Department administers Physics and Biomedical Engineering. Biology Department administers Biology, Environmental Science and Technology, and Biology Master Program. Chemistry Department administers undergraduate and master program of chemistry, and there is also Mathematics and Science postgraduate program, which administered by the faculty.
I'm so proud to be part of FST. As a faculty with national and international standard, FST gives me many facilities to support my academic and non-academic activities, such as laboratories, student center, and sports center. Friendly lecturer helped me to broaden my viewpoint so that I can appreciate toward nature and environment. And the important thing that I have many diverse friends from Sabang to Merauke.
The main vision and mission of FST Universitas Airlangga is to become the leader in developing science and technology and to build and develop civilized, moralized, and environmentally friendly society. To actualize that, FST Universitas Airlangga continues to develop itself to become a better study place and study destination. This is proven by the accredited and certified study programs in FST, both nationally and internationally.
Hello, my name is Muhammad Hashir bin Fadil. I'm from Malaysia and I'm studying in Management and Science University, and I'm taking Bachelor in Forensic Science. So, based on my experience here around a month, I can see the lecturers are more friendly and they're talkative. And when during the lecture, they like to talk and explain more rather than using the slide, because of I think they're more experienced and knowledgeable.
Hello, hi. My name is Nadia binti Norazam. I came from Malaysia. I'm studying in Management and Science University in Malaysia. I'm taking Bachelor of Forensic Science there. My experience in Faculty of Science and Technology here really have a great moment.
In 2016, FST also support Universitas Airlangga's target to reach top 500 world-class university by strengthening the learning system and increasing the publications. The excellence of FST Universitas Airlangga in education, research, and community service is proven not only by the students and lecturers' achievements in national and international competitions and publications, but also reflected by the global networking and collaboration with the industry and other educational institutions in various fields. To support the students' academic and non-academic activities, FST Universitas Airlangga has some facilities, such as fully equipped classrooms, laboratories with advanced research instruments, library with newest literatures, books, encyclopedias, magazines and journals, student center as the core of students' organizational activities, greenhouse, computer laboratories, fast internet access, sports center, mosque, and gazebo.
On behalf of Dean of Faculty of Science and Technology, Universitas Airlangga, I would like to introduce the faculty briefly. Since 2008, Faculty of Science and Technology, Universitas Airlangga is not only producing scientists but is also the engineers with fundamental academic skill for the advancement of modern way of life. We have around 3,000 student international lecturers and many international collaboration including classes, researches and publication. In 2021, we are pleased to say that Universitas Airlangga is currently ranked from 521 until 530 in QS World University ranking and among top 5 universities in Indonesia. It is our mission to create professionals with global perspective, provide excellent opportunities for students to travel and learn from their counterparts all around the world. All staff members have been exercised with new ideas of learning, latest designing and perfecting experimental techniques. Please come and join us and let's face the challenge of creating your journey together.
Selamat datang di program studi S1 Matematika Universitas Airlangga. Program studi S1 Matematika berdiri pada tahun 1982. Berada di bawah naungan Fakultas Matematika dan Ilmu Pengetahuan Alam yang berubah nama menjadi Fakultas Sains dan Teknologi pada tahun 2008. Saat ini, terdapat 4 kelompok keahlian di bawah koordinasi program studi S1 Matematika, yaitu analisis, aljabar, riset operasi dan komputasi, serta pemodelan sistem. Sehingga, dalam program studi matematika, tidak hanya sekedar mempelajari perhitungan rumus-rumus, akan tetapi juga hal-hal yang berhubungan dengan pemrograman. Program studi S1 Matematika memfasilitasi kegiatan non-akademik melalui organisasi yang bersifat ilmiah keprofesian. Sebagai wadah pemersatu, wadah aspirasi, dan komunikasi mahasiswa matematika, yaitu Himpunan Mahasiswa Matematika, yang disingkat Himatika. Himatika didirikan pada 16 Oktober 1983 dan pada setiap tahunnya akan diperingati sebagai Red Day. Himatika memiliki 7 komunitas kegiatan mahasiswa yang tujuannya untuk menunjang dan memfasilitasi hobi, bakat, dan minat mahasiswanya. Untuk mendukung prestasi warganya, Himatika juga menyediakan berbagai informasi mengenai lomba, beasiswa, tutor mata kuliah, dan lain-lain, yang dapat diakses melalui official account Himatika seperti Instagram dan YouTube. Tidak hanya itu, Himatika juga melakukan pengabdian masyarakat yang bertujuan dapat meningkatkan kesadaran terhadap pentingnya pendidikan. Program studi S1 Matematika telah mendapatkan akreditasi A, juga mendapatkan akreditasi ASIIN, Accreditation Agency for Degree Programs in Engineering, Informatics, Computer Science, Natural Science, and Mathematics. Program studi S1 Matematika berkomitmen untuk konsisten mencetak lulusan-lulusan yang penuh kreativitas serta kompetitif.
Okay. Is it my voice clear enough? Okay. Assalamualaikum warahmatullahi wabarakatuh. Good morning, everyone, and welcome to this lecture series hosted by the Department of Mathematics Faculty of Science and Technology, Universitas Airlangga, with special topic Basis Set and System delivered by Dr. Saidali Ahmad Husseini from Mediterranean University of Reggio Calabria, Italy. From additional information to this webinar is included in the quota program from Global Mobility Division, Airlangga Global Engagement, Universitas Airlangga. First, let me introduce myself, and I'm sure that most of our mathematics students already know me. My name is Asri Bekti Pratiwi. I will be responsible for hosting this lecture. And before we came in our main agenda, I would like to invite all participants to stand up and singing of our national anthem, Indonesia Raya. Okay, thank you. On behalf of Universitas Airlangga, I would like to welcome Dr. Fatmawati, who is Vice Dean of Science and Technology Faculty, to deliver a welcome speech in this lecture. So please, Dr. Fatmawati, time is yours.
Okay, thank you, Bu Asri. Can you hear my voice?
Yes.
Okay.
It's clear.
Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Good morning, everyone. Honorable Dr. Saidali Ahmadian Hussaini from Mediterranean University of Reggio Calabria, Italy. Honorable Head of Department of Mathematics, Dr. Heri Suprayitno, and also Honorable Secretary of Department of Mathematics, Kiki Alvinia, PhD, our moderator, Asri Bekti Pratiwi, lecturer, students, and all participants. First of all, I would like to thank Dr. Saidali for his time to share his research experience about fuzzy Z and system. It is an interesting topic, especially in application of the fuzzy Z and system, such as in clustering, data analysis and data fusion, pattern recognition, and also computer vision. I do believe everyone will enjoy today's webinar. I hope today's webinar will not only provide insight to students regarding the application of the fuzzy ZN system, but also become a starting step for collaboration between Universitas Airlangga with Mediterranean University in future. Maybe that is all from me. Once again, thank you to Dr. Saidali and to everyone. Please enjoy today's webinar. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you too.
Okay, thank you, Dr. Fatmawati. And for those of you just joining us, welcome. The attendance form will be provided after the speaker's presentation. And now I would like to ask all the participants to turn on your camera because we will have a photo session. And make sure that you are using the virtual background provided by the committee. Okay, please, all the participants, turn on your camera. Okay, we're still waiting. Okay, please, Helena, you can take the screenshot right now.
I will count ya, Bu. 1, 2, 3.
The next slide, already?
The next slide, there is no
It's
one
okay, I guess.
online.
Yes, it's okay.
Okay, Bu. 1, 2, 3. Done, Bu.
Okay, thank you. Okay, and I hope that you keep turn on your camera because it will bring good vibes to our lecture today. Okay, our today topic is fuzzy set and system, and the speaker is Dr. Saidali Ahmad Hussaini. I will read his CV first. And as we can see, Dr. Sayyid Ali Ahmad Husseini, or we can call him as Dr. Ali Ahmadians. His research interests are fuzzy set and system, fractional calculus, interval computing, support vector machine, neural network, and fuzzy C-means in data science. Now he is an associate researcher in Mediterranean University of Reggio Calabria, Italy, and also affiliate researcher in Kean University, USA. He got his PhD in applied mathematics from University Putra, Malaysia. He has a lot of supervisory experience and also collaboration as professional in several affiliations. And he has a lot of publication in his area. Okay. So please let me welcome Dr. Ahmadian.
So
How are you, sir?
Thank you so much. Can you hear me?
Yes.
Thank
Yes.
you so much. And I think that should say that a very good morning to everybody. It's my pleasure. Thank you so much to invite me. It's my honor to have a talk for today seminar, and I really hope that you can take your advantage regarding this interesting and hot topic subject. So with you, if you think that's time, I can start and share the slide, then let's see that what will happen. Thank you so much. Also the Deputy Dean of Faculty for welcome message. So my pleasure. And also I should thank you all for your great participating in this talk. So thank you.
Okay. Before we start, I would like to inform the participants. Let me explain how you can talk to us during this lecture. If you have any question during the presentation, just write them to the chat box. I will read them on the question and answer session. Or you can wait until the end of presentation and unmute yourself to ask directly to the speaker. Okay, Dr. Ali Hamadian, are you ready? You have time until 10:30, I guess.
Okay, sure. Let me share my screen. Okay, you can see my slide.
Yes.
Okay, thank you so much.
Yeah,
so,
thank you.
Thank you. Good morning again, everybody. The topic is actually introduction to fuzzy setting theory and its application. From the time that Zade proposed this topic in 1965, so we received a very considerable attention to fuzzy settings and also the applications. We have a day-to-day, the increasing number of applications for this hotspot topic. And then if you easily Google or easily find from some famous database like Elsevier, Springer, Wiley, IEEE, then you can see that we can find interesting applications of fuzzy in different type of different field of science and engineering, from mathematics to physics and chemistry or engineering problems. So fuzzy try to address all of the vagueness compared with probability, and so compare with stochastic parameters with the superiority and also advantages that we will address, and also have a brief description during this talk. I hope that it will be take your benefit from this talk, and maybe will be motivated for future consideration if you are students in postgraduate students, or so maybe if you want to make a research collaboration anyway. So you can also contact me, and so contact me, and I will be very happy to support you and collaborate with you, so to make a productive research articles and also common projects. Anyway, in this talk, I will go through the basic concept of fuzzy setting theory, and then so some definitions, important definitions, with the main focus on differential equations. We'll have consider some applications if the time allow me. So let me start. So what's the content that we have here? So the first, we will have a look on the story of the fuzzy set. Where is the origin of fuzzy set? Then we will go through the comparison between crisp and fuzzy logic. So what's the difference actually between these two concepts? Then we'll consider the definition of crisp set, fuzzy set, and also the operation over the fuzzy set. You know that if we want to employ the fuzzy sets, we should consider the operations that somehow are different from the non-fuzzy sets, or we can say that crisp set, or maybe in some reference book they call that deterministic sets, all same concept. And then we will have the membership formulation, and also finally I will go through the important topic for mathematicians related to the fuzzy. We can say that fuzzy differential equations, it's very interesting. We have a different cluster of fuzzy differential equation. Then a part of application of fuzzy sets is coming from this part, fuzzy differential equations. So the last part is we'll have short or brief discussion, if can have time, on numerical methods for fuzzy differential equations, because if you search, you can find a lot of articles related to the numerical methods or even analytical methods for fuzzy differential equations. I believe that maybe more than 50% of these articles are completely wrong. So that's why if I can find a extra time, then I will go through it. Otherwise, so it's interesting topic that you can also search and also consider it in your future research. What's a fuzzy set actually? Or why we need to have fuzzy logic? So we have a very famous quotation from Albert Einstein, say that as far as the laws of mathematics refer to reality, they are not certain. And as far as they are certain, they don't refer to reality. Means that it's a very important quotation. So if we want to consider the mathematics, the behavior of the problems, phenomena in the nature, we want to model them based on the mathematics, then it's inevitable to consider uncertainty. We cannot determine, we cannot model the physical problems, real world systems based on certain mathematics operations. We need to consider some uncertainty in the parameters in modeling, then we can ensure that our model is very close to the behavior of the real world system. So that's why I think that one of the motivation that Zade proposed this concept is related to what we can say that the request to have, or the gap of some similar topics to address the nature of real world system, or the nature of phenomena based on the mathematics, because otherwise we cannot have a good model. So let's see that what we have. What else? So then what's the application of fuzzy set? We have a application of fuzzy set. So the first is related to the fuzzy mathematics. Then we have some application in fuzzy logic and AI. So you know that we can use the fuzzy in a machine learning algorithm, or so like deep learning, or so data science. And then this next part is related to the fuzzy system, like fuzzy modeling, fuzzy controls, and so on. The last part is the application, important application related to fuzzy decision making. We can address the different type of multi-criteria optimization problems based on fuzzy concept, on also, so we can also consider optimization technique used based on fuzzy parameter under, you can say that uncertainty, addressing or considering the fuzzy parameters. So, but if we want to provide a proper definition for fuzzy logic, what we can say, we have a lot of definition for fuzzy logic. One of the maybe suitable one is this definition, say that the fuzzy logic try to give you a method to, that formalize reasoning when dealing with vague terms. So because the current situation based on the classical mathematics is only based on the Boolean ones, 0 and or 1. So we do not have any other option. We should consider 0 or 1. But fuzzy logic give you a new concept. It's called the membership functions and the degree of truthfulness or falsehoods. So then based on this fuzzy membership or membership function, we can not only based on determine or define or problem based on 0 and 1, but also some numbers between these two values, 0 and 1. So this is the fuzzy logic, addressing the traditional concept based on the values not only between 0 and not only based on 0 and 1, but also some values between these two values. So this is, we have a lot of definition, as I said to you, but if we want to simplify the definition for fuzzy, I can say that this is a good definition for fuzzy logic. So then once we say that about uncertainty, we should consider three parts of uncertainty. So we have stochastic uncertainty, means that the parameters based on the stochastic parameters, we have linguistic uncertainty and also informational uncertainty. So this is the type of, maybe once we have in the application of modeling, we will be faced with the title or article including uncertainty, then we should check that which type of uncertainty the others mean, what looking for it, stochastic one, linguistic or informational. So it's important. Then so if, for example, have a stochastic uncertainty, the example is rolling a dice. So we have different option once we rolling a dice, but for linguistic uncertainty, we can consider like low price, tall or so short people, young or old age. They are the type of linguistic uncertainty. So we cannot stay in our day-to-day conversation if we want to say that some price are low or some price are high, expensive. So it's a type of uncertainty inside this type of conversation, and we say that this is the linguistic uncertainty. For informational, we can consider the honesty, creditworthiness, and so on. This is the type of informational uncertainty that including some vagueness, some parameters with vague that we use it to transfer our knowledge. And so we know that we cannot measure them based on classical mathematics. We need some extra information to state them clearly, or so with more, so maybe good interpretation. So this type of uncertainty. Then let's see the example. We will go through the fact that, why we need fuzzy sets. So for example, we say that the temperature is cold and oil is cheap, and then heating is high. So what's the type of this parameter or variable that we have? Here, the temperature is a linguistic variable, and the oil, the cheap, is again linguistic variable, and also heating is a linguistic variable. Once we talk about temperature, it's a type of linguistic variable, or the chipping, we say that the oil is cheap, again, linguistic variable, same for heating. So it's a type of linguistic variable. While for also the adjective here, like cold, like cheap, like high, they are also the linguistic values. We have linguistic variables, and then we need some linguistic values we can state or make a statement based on these linguistic values. So then if we can provide a set with a specific function that can state or can measure or linguistic variables in relationship with linguistic values based on some specific value to measure or feeling, to measure or information, then it's a type of fuzzy sets. So let's go through the definition of fuzzy set. This definition first proposed by Zade in 1973, but actually he initially discussed about this definition is his PhD thesis. So then he proposed in precise information or definition based on an article published on that day. So anyway, so we have a linguistic variable characterized by unique components. So these unique components we call them. So the first is the X's name, then the term set, the universe here is a U, then synthetic rules, and also semantic rules. So this is all the components. If we want to state the linguistic variable, we need to consider all these components. We'll describe in details that what's this component. But so initially, except from me, that if we want to address the linguistic variable, we need to consider all these components. So we have the question that will so reach in your mind that so if we have probability approach, if we have stochastic approach, then why we need to consider fuzzy? Because they already address uncertainty. Why we need to have extra definition with so extra operations and systems? So why we need? Let's see this circle. So if you want to classify these stochastic, fuzzy, and also maybe probability, then we have different islands. So the first part is the whole is a universe. So the first part is a stochastic. Then we have some deterministic parts in the universe. Then we have another island. So it's for fuzzy, uncertainty, and vagueness. And then we have some other non-deterministic, maybe probability, maybe other concept that we still have not been faced with them, maybe in future. Anyway, you can see that stochastic is a distinct concept. So from fuzzy, two separate definition, two different applications. And so that's why we need to consider. In the next slide, I will provide a comparison that why we need to have a fuzzy, but you can see if we want to determine, we do not have any common area between stochastic and fuzzy. However, we can define also fuzzy stochastic parameters or models, fuzzy probabilistic problems. So we have them, but in general, so they are different, completely different concepts. So this is a very, you can say the short or brief story of fuzzy. So the first part, as I said, Prof. Zadeh is recently passed away around 2 years ago. So he proposed in a seminar paper this concept, actually, the foundation of his PhD thesis based on this concept in 1965. So then he proposed the exact definition for linguistic variable based on fuzzy concept in 1973. So first he proposed in 1965, then the first application of fuzzy in control engineering proposed in 1970 in Europe. 1965, in 1975, the logic of fuzzy logic also introduced by some researcher frontiers in Japan, and then we needed to check that it's experimentally it's correct or not. It's only a theory without any supporting of experiments. So that's why it was validated in 1980. This period in Europe, so mostly in Czech and German. So Germany, and on 1985, the applications has been rise in different type of field, engineering and science, not only Japan but also in Europe. And then from 1995, we had the broad application in US, and so actually from 2000, so we had more application, interesting application of fuzzy in data science, and also, machine learning algorithm, business, economics. So I can say that in the past 2 decades, we had a very considerable attention to the concept of fuzzy sets and systems. And if we want to compare, it will make a comparison between crisp logic and fuzzy logic, how we can state them. In a crisp logic that we currently have, or deterministic logic, we say that a proposition can be true or false. We do not have any other option. A proposition or a statement can be true or false, means that the weather is sunny or the weather is cloudy. So it's whether it's sunny, yes or no. We can state it by degree of truth by 0 or 1. We do not have any other option, any other values. But once we want to use fuzzy logic, then we have actually the degree of truth with not only 0 and 1, but also the values between them. Means that if I say that the weather is sunny, then you may ask me this. So the degree of being sunny, how much? Maybe a part of sky is still cloudy. So then I can say that it's not sunny with a membership like 0.65. But if we cannot find any cloud in the sky, then we can say that yes, it's sunny with the membership 1. Or if even the sky is cloudy, no trace of sun, then so the degree of truth is 0. You can see that even if we have a completely cloudy sky, and we still can consider this weather in our sets, but with the membership like 0. So some example also I provided here, like Bob is a student, so it's true. Smoking is healthy, definitely false. But if I say that William is young, then so how much is young? For example, I'm 39. I can consider myself as still young person, also student, junior student, 20 years old, so you can consider the youngest student. But if we have different values for membership. So the first, for me, for example, is a membership maybe 0.5. For a junior student, it will be 0.8. Or for example, we can say Ariel is smart. So how we can state it? Smart is a linguistic variable. How we can measure? So maybe based on IQ test, I can say that if the IQ test is around more than 100, then I can say that yes, the membership should be 0.8, 0.9. More than 100, like 120, then I can say, oh, it's very smart, very clever. With the membership like 1, value will be 1. So as I said to you, once you say that the crisp set means that the current classical sets that we have means that our member here, the elements belongs to the set like A or not. We do not have in classical mathematics, we do not have any other option. However, so the membership also for them is 0 or 1. We do not have any extra value to state them. If it belongs to a set, we call it so the membership 1. If not, then the membership will be 0. So an example like the set of all people, if we call the set of all people like P, then the set of all young peoples means that what's the meaning of young people? The people with the age less than or equal 25. So we'll state them with membership 1. Then you can see that say Y is a subset of P. But if we want to determine the use, so then we consider specific value only less than this value we consider as a young. Why? Maybe we miss some information. Maybe 26 is still young. We know that 30 is still young, but we cannot state them in classical mathematics, increased set like this one. So this is the deficiency of classical mathematics. How about fuzzy set? So I want to compare it. You can see that the function, we have straight line. If we want to state function and take a plot for it, but however, for fuzzy sets, we have somehow even some broken lines or curve to state the values of our fuzzy sets. So I can say that we owe to the founder of fuzzy logic, Zadeh, for providing us this very interesting and considerable hotspot concept that he proposed, and then the frontiers of this research. So after he continued to reach the information to us. So in another example, I want to make a compare and contrast between fuzzy sets and also crisp sets. So for example, we have a traditional representation for classical logic. We have two animals like snail and we have cheetah. We know that snail is a very slow animal, while cheetah is one of the fastest animal on the world. So if we want to state that, so snail is a slow, we should consider for the speed 0. The value for the function is 0. However, for the cheetah, we can consider value equal 1. Then how about the other animals? We do not have any other option. Just we should say that based on slow and fast. Like I can say that for dog is fast and 1. And also for turtle, we can say that it's slow, 0. But we know that there is a difference between the speed of cheetah, dog, turtle, snail. How we can state? It is actually one of the deficiency of classical mathematics. So you can see that in this slide. I want to state the slowest one compared with the fastest one, but considering we have some other animal here, then we can consider a new membership based on fuzzy new membership function for slowest, the interval between slowest and slow, considering the speed between 0 and 0.25, while for the slow between slow and fast, we have other choices, and then we will reach the fastest one. So the speed will be greater or equal to 0.75 up to 1. So this is how we can address the phenomena, linguistic variables, current day-to-day communications based on fuzzy logic there, and also will ensure that it's closer to the behavior of system that you want to define compared with the classical mathematics. Also, for example, we have, if we want to check a table for some students regarding their heights, if we have a degree of membership for Chris one, like for some very tall guys, we should consider 1 for 208 centimeter, 205, 198, and so on. Then from 179, you should consider 0 up to 152. But still, we believe that this guy, like David, still is a tall guy, not compared with the Chris, but still it's acceptable. While for the using the classical mathematics or classical sets, we cannot address it, and we will miss some important information while we could keep them, or maybe it's important, not some simple one, but also for very complicated one, we using the classical sets, we will miss some considerable significant information. You can see that the degree of membership based on Chris is just 2 values, while we have for degree of membership for using fuzzy set, we have a curve to address, to consider all of the possible sets based on the specific value of membership. So, but how about fuzzy, compare, or versus probability? So because maybe you asked that we have also similar function in probability, how we can compare them? So fuzzy actually is definitely not equal probability, while so the membership are definitely not equal. So while they have the border function between 0 and 1, but the problem or the concept of a probability is a measure of our knowledge or ignorance of truth of the event that belongs or not to the set. So probability just check that this or knowledge belongs to the specific set or not. Probability actually dealing with uncertainty, but in a different approach. So in a fuzzy set, we are looking for measuring the degree of blindness of set, not only checking that so it's blind or not to a specific set, but also we are checking for some possibility of, or for some the type of degree of function to check that it's actually belongs, or if it doesn't completely belong, how much we need to consider for the membership function, then our set can be belong to set A. While for probability, we do not have it. Actually, probability is dealing with uncertainty, while the fuzzy logic is dealing with vagueness. Let's see that an example. So in example, we can make it clarify. We have a bottle of water. 50% probability of being poisonous means that, what it means that 50% water is clean or 50% the water is poisonous. It is a probability. Why? Once we say that the 50% fuzzy membership or poisonous means that water has poison, but about 50%. You can see that the concepts are totally different once we will go through these concepts deeply. The probability of being poisonous means that so only 50% we consider a chance for the water be clean, while if we have a fuzzy, then only 50% of the water is poison. So it is actually the difference between fuzzy and probability. So you can see that provide here. So in a membership for probability, we have 0.91. the value for membership function of probability, means that with the z value 0.91, you have a chance that you drink a juice, but for maybe 9% it's poisonous. Why? If we say that the membership based on fuzzy set is a 0.91, means that it's a taste funky, but should not kill you. You can see that the difference between these important issues. So if we want to stay based on the demonstration of the sets, like Boolean set compared with the fuzzy set. So by using an example I provide here, so you can see that if you want to measure your fever based on the Boolean set, you say that if your fever, if you measure is between, so maybe 40 degree of centigrade, 39 or 42 anyway, so you have strong fever. Then out of these values, so you do not have fever. While if I want to stay based on the fuzzy sets, we do not have very clear boundary between all the values in our set. We have some boundaries that are, we can say that it's a vague. So even the 38 degree of centigrade, we have actually we can consider specific value for it and assign a value for membership. This is the difference if we want to explain based on the Boolean sets, fuzzy set, and considering the demonstration of the set. This is the difference between the fuzzy set or compared with classical or conventional set. So means that in a Boolean set, in fuzzy set, we are facing with more or less rather than either or. So this is the important thing. Now we found that why we need to have fuzzy sets, why we need to address it in our current modeling of real world system. Then we try now to revise the previous definition of fuzzy set based on this new important definition of fuzzy set. What is fuzzy set? Say that if U is a collection of all objects that we have, so presented by U, then say that X belongs to a fuzzy set in U if it's defined in this order. Means that we have a member like X, that's belonging to the fuzzy set A with a specific membership. We show it. This is the set A subset of U. This set is called that fuzzy set. Fuzzy set actually is including the members, that each member has a specific or unique membership value. So this is the membership function. The membership function has a board between 0 and 1, including the 0 and 1. This is a closed set. So, and compare with the Chris set, the membership between only assign 1 and 0. You can compare that. If we have membership in fuzzy, so the membership can assign 1 if X is totally in A. But if our member is partially in A, then maybe it can assign a value between 0 and 1. But if this member like X doesn't belong to A totally, is out of the set, then it's time that receives 0. While for Chris set, we do not have such option. So let's see an example. So this is a fuzzy set. So you can see that we have different value 1, 2, 3. Each value has a specific membership. So this is our universe, and then we can call that it's our fuzzy set with the specific memberships. So this is the type of discrete, fuzzy discrete mathematics, showing the discrete sets based on the memberships and defining them based on the fuzzy membership set. So it's a very important, maybe sometimes you can see that this representation in the textbooks, but it's not very common. Usually we use this for only discrete type of fuzzy set, not for continuous one. But if you want to define a continuous fuzzy set, how we can state it, just state the parameter with the specific function, continuous function. Like this example, if we want to define the function for all the guys maybe about 50 years old, then the membership function is defined like this function. So this is a very continuous function. We have this curve to state it. Even once we say about 50 years old, a person with 50 years old means that you can see from the curve, we still can consider the 40 years old in this set with a maybe lower value of membership function, but still belong to this fuzzy set with a lower value. So while if you wanted to consider the classical mathematics, we do not have such options. So then we have another alternative representation for if you want to denote the fuzzy function. So fuzzy sets, this is the first, the most common one. Also, we have this one in the textbook or maybe articles. So but these are some more common, specifically for the discrete one, the fuzzy discrete mathematics or fuzzy discrete subsets, we use this notation. This doesn't mean that we have a summation. It just stands for showing that we have discrete, fuzzy discrete set, while for fuzzy continuous one, we use the symbol of integral, but it doesn't mean that we need to take integral, just the notation. So we have fuzzy sets, the new sets. Then we cannot use the old operations or classical operation for our new set. It's not actually usable. So cannot be effective. Why? So that's why we need to define the new operations. So the new operations is based. We have a lot of fuzzy operations. Even, for example, if you want to make a fuzzy summation, depend on the problem, maybe we select different definition for fuzzy summation. I have listed some of them. For example, for summation of two sets, we consider the maximum value of each element, the membership ones, while for the intersection, we consider the minimum or complement, we consider what the membership, I'm talking about it, 1 minus mu. So anyway, we have a lot of fuzzy logic operation definition. We will describe the most common ones, while we have maybe if we want to employ them for different model, then we need to check that which one is more suitable. And also we have some other definition like support of a fuzzy set. So it's the lengths between the left side, or between, you can say that the first value of the fuzzy set and the difference between first value and last value, we say that this is support of A, the support showing by sub A, trying to help us to determine the not whole of fuzzy set, but maybe some other values out of sub fuzzy set. So it's not just showing some operation. We need to fuzzy probability, but not very applicable in fuzzy mathematics. And we have also core. They are the, you can say that they are the definitions that help us depend on problem, that help us to solve our problem or define our problem based on fuzzy set. But the most important definition is the alpha cut. Once we have the fuzzy sets, we usually do not use fuzzy membership function directly. We use some new concept. We say that alpha cuts or sometimes R cuts. We use some cuts to cut the fuzzy set to some crisp set. Then we are trying to solve them based on some crisp set. Then finally we add all of the crisp set, transfer again to the main domain of fuzzy that we want, then we interpret. So that's why alpha cut of fuzzy sets is important. Means that the alpha cut actually are crisp set that help us to operate or work or compute the fuzzy sets based on maybe numerically, analytically. Then finally we'll back to the fuzzy set and showing them based on fuzzy set. Why? So solving directly or dealing directly with fuzzy sets sometimes is not common or complicated. So that's why we need to have alpha cuts. We have some other properties of fuzzy set, like height of a fuzzy set. The height of a fuzzy set, we have also, this means that the height is actually the support of the fuzzy set. If our height is equal 1, so means that the maximum value for our membership, if we consider the 1, then we say that our fuzzy set is normalized. And similarly to the classical mathematics, we have a convex definition for the fuzzy set. So a fuzzy set, we call that it's a convex once the membership of summation of lambda x plus 1 minus lambda y should be greater or equal mean the mu a and mu a y for any mu ax and mu a1 for any two members belongs to our universe. If our fuzzy set satisfying this inequality, then we call it our fuzzy set is convex. So you can see that we want to check that, or from the figure, so our fuzzy set is convex. Then so you can see here we have two convex fuzzy set, while we do not have convex fuzzy set here, because if we want to connect 2 points of fuzzy set together, then they will be out of the domain of our fuzzy set from the figure I'm saying. But if you check it, this inequality, then it's satisfied. But from here, you can see that if we want to connect any of 2 points from the fuzzy set, then still we are in the fuzzy set. So how about the membership terminology? So what we have in the membership function, if we want to classify, so the support of the membership function or support of the function that we have is the biggest part or cover the biggest part of our membership. Sorry. And why? For alpha cuts, it's a smaller part because we can define several type of alpha cuts. So with these different values, for y's of the fuzzy, we have smaller parts actually limited to smaller part, while for the core is the smallest part of membership. They are the actually as you know, that it's helping us. This is the fuzzy operations definition that help us to dealing with the membership function. Try to simplify our computations based on normality, fuzzy singleton, fuzzy numbers. It's very important, symmetricity and other things. The most important thing, so in these terminologies, is related to fuzzy members. Very important. Why? Because we are usually dealing in fuzzy modeling, we are dealing with a fuzzy members. A fuzzy member is actually a fuzzy set on real line R satisfying two important properties, convexity and normality. If our fuzzy sets satisfying these two important properties, then we call it's a fuzzy number. The rest are more important for actually pure mathematics, and maybe if you want to work for fuzzy algebra, then they are very important. But for applied mathematics, physics, engineering problem you want to model, the fuzzy number, this definition will be very important, play a very important role. So then we have subsets, complement, union, intersection. There are also other definition and operations of fuzzy set. We can say that two set. So A, like we can say a fuzzy set A is a subset of B if or only if the membership should be less than or equal from the another one. So how about the complement? If we want to define a complement, fuzzy complement, just we need to consider the membership is the 1 minus the membership of the original set. For a union we have, so the union of two sets is coming from maximum of all these elements one by one. We should check to define the maximum one. We have different definition for union, but I'm talking about the most common one, intersection. So we should consider the minimum while for the union we should consider the maximum value between membership function. This is an example from the fuzzy discrete set. If we have A and B, so both are fuzzy set, then if we want to define the union, the universe is from 1 up to 10, then the membership, so we should check that between, for example, here the member is 1, but while we have in B, we do not have in A, so the maximum value for member is only, this is the 0.3, while for 2 the membership, so the element 2 we have in A and also we have in B, then we should consider the maximum value is 0.6, while for others similar. But for the intersection we need to consider the minimum ones. This is how we can define. Then the output is a, so the union of A and B, we showing this is also again a fuzzy set. So you can see if we have a fuzzy sets like A and B, here you can see A is a subset of B. Based on the morphology, you can see that the B is a greater based on membership than A, or if you want to make a union, the output will be such figures because we will consider all the elements from A and B. Why? For intersection, we can only consider some of the common ones. And so the complement is a 1 minus the membership of the function. This is the terminology based on the figures to make it clear. So, but compare with the classical mathematics, we have something that already there in classical ones, mathematics, while they are invalid for fuzzy properties. So for example, the intersection between A and A bar, so is null, so it's not actually valid for fuzzy. Still, we have some maybe elements in common between A and A bar, and also so this is also wrong. Say that A and the union with A bar, so we have the universe. No, it's strongly invalid. We have some other thing. This is the important difference between the classical mathematics compared with the fuzzy. So we have others. I want to move quickly. So we have others also, as I said, the definitions for union, for intersection, like this one. So but depend on, I said you again, depend on the problems that we have. We need to take one of them. This a lot of definition that we have here, like this one. So, but the most common ones that I mentioned at the beginning. So we have fuzzy number. One of the most important concepts in fuzzy sets is fuzzy number, because if I want to model based on fuzzy differential equation a real world system, then I should define the parameters, initial value problems, function, all are defined based on fuzzy numbers. Otherwise, I cannot suitably, or I cannot comfortably work with the fuzzy differential equations. I should have the fuzzy numbers, then the next step alpha cuts, then we have the suitable or proper fuzzy model that we can start dealing with. But the definition of fuzzy number is important. I already explained a fuzzy number should have some important properties. It should be at first a normal fuzzy set, means that the maximum value for membership should be equal 1. The alpha levels or alpha cuts must be closed for every alpha between 0 and 1. So, and also the support of A must be bounded. Means that, or we should have convex fuzzy set, and it's also at the same time, or fuzzy set should be normal. So that's why we call it fuzzy. So we have a different type of fuzzy numbers, triangular, and also so bell shape, or also different type. The most important one is actually triangular. So like this one is a fuzzy number. We usually state the fuzzy number based on the alpha cuts. Means that we have different value for cut. Alpha, maybe alpha cut here, if or function, you can see that it's a normal function between the value of membership between 0 and 1. Then we select specific value for alpha. We state it based on this interval. Explain that what's the meaning of this one. So we state based on the alpha cuts. If we want to show the fuzzy number, usually state based on this definition. So different type of fuzzy numbers, like you can see from these figures. If I state a fuzzy number, so compare, you can see, so a fuzzy number, so demonstrating based on alpha. So if we state it, for example, here is alpha equal 1, then another fuzzy number is 0.7 up to 0. So you can see that the set with the alpha 1 is the smallest one compared to the biggest one, that the alpha cut is equal to 0. So while we expect, like in fuzzy, like in classical set, we expect to have a, for example, bigger one for 1, but the smallest one was 0. While we have here, you can see that if we select alpha cut is equal to 0.2, then we have a bigger set of the values for fuzzy numbers, while for the considering alpha is equal 1, we have a very smaller one. This is the for properties of fuzzy number that we need to consider. It's very important, interesting at the same time. So we have triangular fuzzy number. Is that triangular fuzzy number like triangular shape? So we show it sometimes by 3 elements. And so here is an alpha cut, is an alpha cut for alpha equals 0. So should we show it with the left bond and also right bond. The left bond with the z minus, the right bond z plus. It doesn't mean that it should be negative or should be positive, just a notation. So, and also the triangular fuzzy number showing by 3 elements, the left one, right one, and so we can say that the core z1. So, but still, for triangular fuzzy numbers, we can show only with 2 numbers. So we have different membership formulation because we have different type of fuzzy number, like triangular, trapezoidal, Gaussian, and also bell-shaped membership function, depending on the type of membership, type of fuzzy number, triangular, trapezoidal, Gaussian, or bell-shaped. Then we have different type of function for membership. So the most popular one is the first is triangular, then the trapezoidal. The next one are more applicable for probability modeling that we need to use fuzzy probability. But specifically the first one is if you are a mathematician or if you are from applied mathematics, you want to actually use it for your modeling, you are dealing with triangular one. So, and you can see that their demonstration, triangular, trapezoidal, Gaussian, and also bell-shaped membership function, different type of shape or formulation. So, you know about the fuzzy set. So, but it's not enough to start or working on or dealing with the fuzzy set. We need to have some extra thing, like what's the fuzzy function? If we have fuzzy function, what's the derivative of fuzzy function? Then try through the, that if we know about the derivative, if we know about the integration, so then the next step is that how we can make fuzzy differential equations. So let's see that what's the actually fuzzy number based on the concept that is applicable, or what can I say, that is very popular once we want to go through the differential equation, fuzzy differential equation. This definition proposed by 2 important researchers in Fuzzy, Diamond, and Cloeden. So, and around, I think that 1985 or 1987. They said that if you want to apply a fuzzy number for your differential equation, you should check that again, the same, but just more specific or more, can say that precise formula. So it should be normal or your fuzzy set, then should be convex. Then it's a new concept, and we can say that upper semi-continuous, and then compactly supported. If or fuzzy set has all of these properties, then we can say that it's a fuzzy number. So usually we denote the space of fuzzy number by this definition. So by this symbol RF. So R is coming from real number. Then you can see that the board is between 0 and 1. Then the set of all fuzzy numbers, we show that by RF. Maybe some other symbol we have, but actually the common one is this one. Like we have here the fuzzy set. We need to check that this fuzzy set is a fuzzy number. So if we check all the properties consider normal, fuzzy convex, upper semi-continuous, and compact, then we can ensure that it's actually a fuzzy number. So like this one also, we can check that it's a fuzzy number regarding the formulation. So it's important to know that if you want to start to work with the fuzzy, then better to select to working with the fuzzy numbers, not the fuzzy sets. So working with the fuzzy number is a more so easier, or so with a lower degree of complexity. But the next step is that if we want to using the fuzzy numbers for computational working, then it's better to consider alpha level sets or R level set, R level set. You can see that R level set. So it's a very common notation or common definition. So R level set means that all of the X belongs to R, that the membership has a value greater or equal than R. Then we show it, this is the alpha cut or R cut, and this is the set that we are looking for it. So it's a, we call that if or alpha is equal 1, then the level set will be the core of fuzzy number, while for the alpha equal 0, the level set will be the support of fuzzy numbers. We here have an important theorem called stacking theorem. I bolded this because it's very important. You say that it's a stacking theorem, say that if we have a like U belonging to RF is a fuzzy number, then the level sets are defined like UR is a closed interval. This is the level set. And also for any alpha cut, if R1 is less than or equal R2, then the level set or alpha cut bit or R cut between this R2 is a subset of the level set based on R1. Then we have some other detail regarding the convergence and also some more important thing. So I prefer to not go through the details. Maybe so it's just point out briefly. So then if you will be interesting, in working on this, then these are the that important theorem and definitions that you need to study to be skilled of working with them. Another theorem is a characterization theorem, help you again like the stacking theorem to classify or to determine that you as a researcher properly classify or get the set of alpha cut or R cut or not. It means that your R cuts should satisfy this theorem. It's called Neguita-Ralski characterization. Why? Because we have some other characterization theorem. This is one of the oldest one for fuzzy. So, and then we have the Goldshell-Waxman theorem. So for presentation of the fuzzy numbers based on the left side and also the right side, means that lower or upper, LU. So it's a type of demonstration for fuzzy numbers. We have several type of demonstration based on alpha cuts. You can see that here is the alpha cut or R cut. They are same. Sometimes in notation we use R, sometimes in notation we use alpha. So that's why they are same. Then so it's very important theorem that if we have the alpha cuts or R cuts, then or R cuts should satisfy some conditions, means that the left cut, the left side of our R cut should be bounded non-decreasing and left continuous function, while for the right one should be non-decreasing left continuous function and also right continuous at 0. These are the important things that you want. If you want to get the alpha cut, then you need to take into consideration. We have fuzzy functions. So it's a very old fashion definition for fuzzy, but you know that once as a researcher, I want to be very skilled on fuzzy sets. I want as much as even if you are postgraduate students, you want to start working on fuzzy, it's better to have a look to all the related articles from 1987 on fuzzy mathematics then till now. So, and with the main consideration of on most recent one, then help you to be very skilled person or researcher on fuzzy function. I just wanted to provide in this slide to keep your attention that the fuzzy function and operation has a lot of, it's a very vast area. Then you can take your advantage based on your fields, not only mathematics student, but also engineering one. They don't need to go through these details. They are very important if you want to work on computational works. But if you are coming from engineering, then you can ignore them. Just take the important one like fuzzy number, fuzzy differential equation, fuzzy systems, then start your works. This is the background that as much as you know, so make your understanding from the fuzzy sets more clear. So scalar multiplication, or sum and scalar multiplication. So we have different type of, again, for example, if we have we have two triangular, you can see that we demonstrate them by three values. They are the two triangular fuzzy numbers. Then the summation based on these two definitions is coming the output like this one. While for the multiplication, we following this notation and operation. If you implement this, it's very easy considering this definition. So while we have some other operations for discrete and continuous fuzzy numbers, the most common ones are coming from the old theorem proposed in 1987 and up to 1990. So they are the boys and prey. So they are very, very frontier researchers. This guy is currently the editor-in-chief of fuzzy sets and system in Elsevier, one of the old and most famous fuzzy journals. Also for product of two fuzzy number, as I said, we have a lot of definition for fuzzy operations, summation, multiplication, a difference. So, and day to day, maybe I'm talking today, next year, if I have a discussion with you, I propose some new definition that trying to, make your operations, make your computation easier for you regarding the fuzzy definition that we have. So here is the most common ones for product of two fuzzy number based on the minimum value of multiplication of the left bound and also right bound of two fuzzy numbers, considering the alpha cuts. If you want to work on computational models, again, I insist on the fact that you need at first extract the alpha cut, then start to work. So maybe you will face with this notation. This notation stands for the fuzzy multiplication. Say that if you want to find the multiplication of two fuzzy numbers, so then you need to follow the theorem or proposition. So considering that for the left one of our fuzzy output, so we need to follow this statement, and while for the right part, you need to consider it. Then the output is the multiplication of two fuzzy numbers. Again, you can see that in computational works, we usually demonstrate or using alpha cuts, not directly using fuzzy numbers with the membership. So these are some propositions help you to understand that why we need to, if you are looking for the multiplication of the fuzzy numbers, then considering the assumption that or fuzzy number hold like +1 or -1, then what will happen about the output? They help us actually. If you want to deal with the theorems, you want to prove some theorems in numerical works in dynamic systems, then you need to have knowledge about what will happen if our fuzzy number is positive or fuzzy number is negative. Then you should refer to this proposition. You can see that step by step from the time that proposed the fuzzy set, then fuzzy numbers, then the operation. We have some more progressive. These, like the band beta, they are the more recent researchers compared with the other researchers that we had in 1987. They are still very new, or the followers coming from the old ones. They are trying to propose new concepts. So like the cross product of two positive triangular fuzzy number. So then we should follow the this definition, and considering this example, we are talking about cross product, different from product. So if you want to find the cross product of two fuzzy number positive triangular ones, then you need to follow this way. So and also the difference of fuzzy number. This is the part of, I can say that the most challenging definition in fuzzy is a difference of fuzzy numbers. Why? Because from 1987 that these guys proposed the difference of fuzzy numbers, then started, we have a lot of articles working on fuzzy differential equation, fuzzy systems, and being based on fuzzy differential equation again. Then they employ this notation or this definition. After that, for example, from 2008, some others found that this definition is not completely correct. Then they propose a new definition to revise it, and they call generalized difference. Again, then we have another version of difference in 2015. Then again, they revised till now. So they're trying to address this important difference of fuzzy number. Why? Because if you want to implement any computational methods for solving differential equation modeling, then you need to be very careful of this, the difference of fuzzy numbers. It's not easy as like maybe we have, I can say that, yeah, confidently 50% of the articles based on computational models and numerical works are, and fuzzy ones I mean, are completely wrong in the, if you Google, if you check in the Science Direct Elsevier. Why? Because they have not considered some properties of fuzzy numbers regarding the difference of them. So that's why it's a very challenging concept. You should be very careful. Again, we are dealing with the alpha cuts, not directly solving, dealing with the fuzzy numbers. So, as I said, I think that in 2009, these guys, Stefanini and Bede, the first from Italy and second, now currently is original from Romania, currently is in US. So they propose a revision of the difference of two fuzzy number. They call it generalized Hooke-Quara difference. The Hooke-Quara difference refer to the fuzzy difference if they say that fuzzy Hooke-Quara difference. Otherwise, the Hooke-Quara difference has a very older background compared with the fuzzy Hooke-Quara difference. They're defining a new concept for the fuzzy difference, considering this definition, then satisfying this proposition. We do not dealing with this theoretical definition while we are dealing with this applicable ones. So we need to take into consideration in our numerical works or even modeling. So we use this generalized Hukuara difference. So it's a very update definition compared with the previous one. And then, so for example, if you have a trapezoidal fuzzy number, you can see that we show it with the 4 elements. And also triangular fuzzy number with 3 elements. We want to find the generalized Hukuara difference. We should exactly address in this proposition to find the values. It's a very actually in practice. So don't confuse yourself that wow, it's a very, very complicated definition, proposition, theorem. How can I start working with the fuzzy numbers and fuzzy differential equation? Better to give up? No. Just some definitions, some proposition and theorem that in practice are very easy for implementation. The details for even mathematics student maybe will be scary, while it's a very, in practice, we have some not very complicated concept that you need to deal with. Just, I want to propose you listed here to give you the approach that what is the area that I want to work in. Very interesting. If you be skilled in fuzzy, then, or as a mathematics student, as a engineering student, or so, then you will achieve a very good skill to dealing in another part, hot spot of science. Then you can develop it. Maybe I'm computer scientist, I can develop it in a K-mean clustering, support machines. If I have fuzzy knowledge, then let's see that, wow, it's a very interesting concept. So anyway, so if this is another new, as I said, so we have still the challenging part of fuzzy difference is the challenging part of fuzzy is actually fuzzy difference. Again, another definition proposed by Bede and Stefani. I think that this one is proposed in 2015, if I am not mistaken. So they proposed this new difference. Still, I can say that from the oldest one, the fuzzy difference, till the newest one, all of them are applicable, but you are the person to select that which one is suitable for your model. All of them can be applied, but needs to consider which one is more important. Then we have the metric spaces of fuzzy numbers. So interesting part is more for pure mathematics. And what can I say that it's for us, maybe for me as a researcher coming from applied mathematics, so they are only the tools that help me to define my problem. But for pure mathematics, very interesting topics that they need, for example, they need to address in their article, their research work. So we have compared with the classical mathematics, we have a fuzzy Hausdorff space. So defining like this one, this is the metric space for fuzzy Hausdorff. So it's coming again, you can see that we usually dealing with the alpha cuts. Through the definition, through the proposition theory, we do not be faced with the fuzzy numbers directly. Instead, we are dealing with the alpha cuts that makes our problem easier. So like this metric space, I prefer to pass to save the time. So then we have a norm of fuzzy numbers. So the norm is similarly to the norm in the classical ones, just some simple difference for the norm of a fuzzy numbers. You can see that here, if we will face with this notation, means that this is a fuzzy difference. Then beside it, we put some index, depending on index, it's referred to a specific type of fuzzy difference from Hukawara difference up to generalized Hukawara difference or generalized difference. So then we have also the integration. You know that we have the derivative, then integration, then so we can have the differential equations, means that the fuzzy, actually the first definition proposed by Diamond included. So they propose that if you want to define the fuzzy integral, the board of the function, you can see that this is a fuzzy number. So that's why we have a fuzzy function. So if you want to consider the fuzzy integral, so you satisfy the normal function should satisfy the in this inequality. So considering the fact that you're trying to say that the normal fuzzy function should be bounded by a specific function. But for you as students, it's important that if you have a fuzzy function, you want to get the integration from fuzzy function, you need to have again the R cut or alpha cut of the function. Then you start to dealing with it or getting the solution of this type of integral. So we have the Riemann, then with some operations over the fuzzy integral satisfying the same in the classical mathematics, like the summation of two fuzzy integral of fuzzy functions. We can divide them, or in inserting the multiplier, we can take it out, or so anything. So it here we have some similar operations, some similar rules, I said, that precisely satisfy also for fuzzy area, like in classical ones. Then so we can, if we have this function, then just needs to follow it for the implementing the actually getting the integration from our fuzzy function, like this example. It's a green function, help us to how we can integrate using the previous proposition. They are very not, I can say honestly, it's not very easy, but not very complicated. So if you study the articles related to the fuzzy numbers, fuzzy integral, then you can see that, oh, you have a very interesting topic. It's not very too much complicated. Then we have another topic, is the differentiability of fuzzy number. It's very important. We have integral, we have differentiability. This is, you know that because we have a challenging point of problem like fuzzy difference, then at the same time we have challenging issue regarding the differentiability, because in the differentiability, as you know that in the classical mode we have the minus. This is here also for fuzzy, we have the minus but different notation. That's why we have different type of fuzzy differentiability. Why? Because we have, based on the difference, we have the Hukawara differentiability, we have generalized Hukawara differentiability, and also generalized differentiability. Depending on the problem, you can select it. So I don't want to go through these details. And so you know that before maybe 2008, so the researchers try to refer or try to use this definition of differentiability. Why? From 2008, they found that this differentiability is not completely correct for some models like gross and population model. This type of differentiability doesn't work. So that's why from 2008 and after that, they found a new type of differentiability based on generalized differentiability proposed by Bede and Gall. Using this differentiability help us to model the real world system closer to the behavior of the system. It's very important thing that we need to learn if we want to go through the modeling based on fuzzy notations and also fuzzy differential equations. So we have actually fuzzy generalized Hukawara differentiability and fuzzy generalized Hooke-Euler derivatives. So they are very useful if we want to start working with the fuzzy differential equations. I passed the important theorem. So these theorem actually help us to how we can construct the fuzzy differential equation based on fuzzy differentiability. All these theorems, you can refer to them regarding the references provided here. I passed them to, for example, I have here to the lower bound and upper bound of our fuzzy number, fuzzy function that are defined based on fuzzy numbers. And here is the alpha cut. You can see that alpha cut here. You can see the trace of alpha. This is the lower bound. This is the upper bound. So we can say that it's a generalized differentiable or Hooke-Euler differentiable, fuzzy Hooke-Euler differentiable, or generalized Hooke-Euler differentiable. These concepts, so don't confuse yourself, your mind. So because all of them has a specific definition, you can find very interesting. I do not have time to go through the details, but the last part is regarding the fuzzy differential equation. We have fuzzy integrals, fuzzy derivatives, fuzzy numbers. Then how we can define the fuzzy differential equations based on who first.
I'm sorry, Dr. Ali.
Yeah.
This you can make it shorter because we have a limited time.
Sure. So we have the fuzzy differential equation based on different type of differentiability, Hooke-Euler differentiability, generalized Hooke-Euler differentiability. Then, so you can see that this is a fuzzy differential equation. See the trace of fuzzy number inside the fuzzy differential equation. Very, very interesting. Lot of applications I can show you. So in the gross population model, neural networks, support vector machine. So depend on the problem that you want to work, we can select specific part that will help you to make a model closer to the behavior of the system based on the actually fuzzy concept and fuzzy differential equation. And so these interesting and hot spot me. So thank you so much for paying attention to this topic. I'm now ready for any question, remark, comments from the respective audience. So stop sharing. And okay, thank you.
Okay, thank you, Dr. Ali. Great explanation about the fuzzy set and system, especially the fact that we can find a lot of pure mathematics in this discussion. Okay, now we come to question and answer session. We already have a question in the chat box from Mr. Muhammadun. Okay, would you like to ask by yourself or?
I'm just reading that. It's a bit long. So it's explain fuzzy is a general form of classical Cris, or in other words, the Cris set is a special case of fuzzy set. What I wonder is whether all operations can be applied. So no, good question. That actually as I said so we cannot transfer all of the operation in classical sets to fuzzy sets. As I said that, for example, we cannot say that the intersection between the fuzzy set and the complement set is a null. No, we cannot say. And at the same time, the union of the fuzzy set and complement set is not universe, sorry. So it's a difference between classical one, but some of the operations we can transfer to, like differentiability, like difference, we can transfer to fuzzy sets, but we should be aware that if you want to transfer, we need to respect the rules holding in the fuzzy operations. Then we start to check that it's if or transferring the operation holds the previous rules, then it's acceptable, otherwise not. And the next thing, that the fuzzy rule is not a general concept of the Cris. No, it's not general. It's another concept beside the crisp one, trying to address as much as we can the informations in universe. Means that if I'm currently in Australia, so in Melbourne, that now today is right 20 degree of centigrade, the temperature. In Indonesia, maybe 28. And in Canada, maybe in Toronto is 8. So then if we want to explain that the weather is hot, for me, 20 degree of centigrade in Melbourne is hot, quite hot, while maybe for in Indonesia for you is not, or in Toronto 8 degree of centigrade is not. Then how we can explain, how we can address these feelings? We cannot do it based on classical one, while we can consider based on some specific sets, like we call that fuzzy, with specific fuzzy membership function. For me, that I feel that is hot, maybe actually the membership should be 0.5, in Indonesia 0.8, but in Toronto the temperature is 8 degree of centigrade, then we can call it, for example, 0.2. You can see that considering this membership, we can define or we can transfer our feelings into mathematics. Fuzzy, in general, try to help us to interpret our feeling or linguistic variables or linguistic values through the mathematics tools, and then compile them based on this rule. And so it will be valuable for industry, will be valuable for education, engineering problem. So scientists to then make some analysis and find some new outcomes. This is, as I say, that this is the main aim or main mission of why we need fuzzy.
Okay, thank you. Mr. Muhammadun, is it enough? Is it clear enough? Or
yes, clear enough. Thank you.
Thank you.
Okay, any other question? You can raise your hand and ask directly to the speaker. Any other questions? No? Okay, Mr. Alia, I have read some of your publication on fuzzy differential equation, I guess. It's quite interesting for us because our research group, I mean another research group, not on the operation research, also works with this kind of differential equation system. So could you please give us a little peek or a little explanation about this fuzzy differential equation, and what are the differences between the fuzzy differential equation with the ordinary differential equation, and probably the implementation?
Oh, okay. Thank you so much. So actually, the fuzzy we say that in classical mathematics we say that differential equations.
Yeah.
Why? We have in fuzzy, we say that fuzzy differential equations. So means that, again, we have till this point, we have not classified the differential equation. We have in classical mathematics, we have differential equations. Then in fuzzy mathematics, we have fuzzy differential equation. Now, if we want to classify, we can say that in fuzzy mathematics, we have fuzzy ordinary differential equations, fuzzy partial differential equations, and some other fuzzy delay differential equation, fuzzy stochastic, while so conversely in classical ones we have differential equation, fuzzy ordinary differential equations, partial differential equation, delay differential equation, and so on. So means that if we want to precisely address which type of differential equations we want to work with it, we need to know that the model so needs to be constructed based on which type of differential equation. Ordinary ones, then we need fuzzy ordinary. Partial differential equation like heat or Poisson equation, then we need fuzzy partial differential equation. So we have some similar classification like the classical mathematics, but we need to insert the fuzzy parameters, fuzzy functions, fuzzy initial values to make our problem fuzzy.
Okay, thank you. Okay, any other questions from the participants? We still got about 5 minutes left.
At the same time, that once they are checking that they have any question or not, I can say that if or students or lecturer fellows so interested in working on fuzzy sets and systems, like not only mathematics but also computer science, economic. So because actually you know that like even what can I say? We recently work on the IoT, Internet of Things, and considering the fuzzy inside it. The article already just published, I think that a couple of weeks ago in the journal. You can trace in my resume. So anyway, on that part also we consider fuzzy. Means that if you are interested working in these parts, also we can have a collaboration or support, and then so. Like current situation, COVID-19, how we can, even we have a pandemic, this is the uncertain condition, then as I am affiliated also in the K University Institute of Pandemic Research, USA, so that's why it will be very interesting collaboration in this way, make a productive research. So I will be always eager, and please welcome to contact me through the email, and so I will be happy to support and collaborate as much as I can.
Yes, thank you. Okay, since there are any more questions, so I guess we are in the end of today's webinar. And now I need to okay, what this is. Okay, just attendance list.
Pakai bahasa Indonesia boleh enggak?
Boleh, silakan.
Oke. Masalahnya bahasa Inggrisnya enggak friendly. Ya, makasih. Saya Hari PS asal dari Jombang, tapi sekarang di Pacitan. Tadi saya tertarik di judul itu fuzzy set and system. Dan saya tunggu untuk sistem fuzzy yang pernah saya baca-baca, itu kan ada step defasifikasi, ada step mesin inferensi fuzzy, dan fuzzification, di mana fuzzifikasi itu kan ada beberapa jenis formula, dan mesin inferensi fuzzy itu kan bisa kita definisikan dengan beberapa membership function. Terus juga pada defasification proses itu kan ada beberapa jenis juga. Nah, dengan melihat karakteristik data kita, bagaimana cara menentukan 3 kombinasi dari rumus fuzzifikasi? Kan ada beberapa rumus, membership function juga ada beberapa jenis, terus sama defasifikasi kan ada beberapa rumus. Nah, untuk menentukan kombinasi yang pas untuk data kita itu biar pemodelan kita itu maksimum, caranya gimana? Makasih.
Okay, thank you, Mr. Hari. Okay, we have a question about fuzzy system. He said that there are a lot of steps in the fuzzy system: fuzzification, inferential system, yeah. And then
inferential machine engine. Yeah.
Okay, and then membership function, and there are a lot of kind and formula on this classification. So the question is how we can combine all this information to create a good model in our system based on the step below, just like a membership function, and then the classification, also the machine inferentation.
Bisa memperjelas enggak, Mbak? Misalnya, sorry ya pakai bahasa Inggris ya, karena Saya bisa mengartikan tapi ngomongnya nggak friendly gitu.
Nggak apa-apa.
Okay. I will try to speak in English. My question is how to find the combination of type of falsification formula, and then type of membership function, and then type of the falsification formula, in order that depend on our data characteristic, we can get the best model like that, Mr. Ali. Thank you.
Thank you. Yeah, clear.
Or just using try and error like that.
Thank you so much. And I first say that thank you to ask this question in a actually language that I miss, because for years I was in Malaysia, and so I think that the similar language, so I have not here. So it's interesting. So send me in the back. So also once I was there, so I had a very good memories from Malaysia, while I was also one time in Indonesia and Bali Island. So anyway, thank you for your question, Fred. So the issue is that I said in the middle of my presentation that if you want to be skilled at which type of characterization, which type of theorem, definitions on summation, difference, multiplication, selecting even differential equations, which type of different definition that I have, because we have a lot of, so is more suitable, help me to model, then it's inevitable. You do not have choice, you do not have other choice except to read the literature review very carefully. Means that once I was a beginner in fuzzy, I started to read the articles from 1987. So started from that time, because my PhD, the thesis was focused on fuzzy. So from 2009 that I started my PhD, I focused on the articles from beginning related to the fuzzy concept. I read the textbook, the main textbook. And so step by step, once I moved forward and solve the problems, I found that some of the information that I need now currently is useless for me. While on that time, I could not determine if I, for example, select this color difference definition, so it's maybe not very applicable for our current model, today models in electrical engineering. But on that time, I found that if I want to be skilled, I must review the literature carefully. Otherwise, if I am a computer scientist, and if you are the computer scientist, refer to me that I want to fuzzify the support vector machine based on fuzzy concept, then what is your suggestion? So I maybe give you some article that if you want to work on only fuzzifying the support vector machine, then you need to, for example, 10 articles, read 10 articles, 20 articles plus one book. It's enough for you to receive a basic skill. Then you can do your work. So because you do not want to work deeply on or do the research deeply on fuzzy support machine, you want to use it as a fuzzy as a tool. So, but if you, again, computer scientists, refer to me that I want to be skilled and on fuzzy machine learning and develop new idea, novel idea for fuzzy machine learning, then I can say you do not have any other choice except to read the articles from maybe 1990 till 2021. Otherwise, you have deficiency knowledge Otherwise, it will lead to the lot of wrong articles that even publish in high prestigious database like Elsevier, Springer, Wiley. Actually, as you maybe you know that I am the editor of several high impact factor journals in Elsevier, Springer, Wiley, so top journals. But even I am as an editor sometimes receive the articles from prominent researcher in the world with their PhD student that have some serious problems in the articles that the senior researcher did not pay attention or maybe was busy, and then PhD student think that has enough confidence to propose this idea, but I could find that the trace of deficiency of knowledge. Then I have to reject the article directly. Maybe my colleague will be sad, contact me, why you rejected my article? Then the problem will again back to him. As a supervisor, you should conduct your students or ask him, force him to read the literature completely, not with 2-3 articles. They say that, oh, professor, I'm very skilled now, I can do fuzzy, I'm a fuzzy expert. No, it's not a straight word that I say that which type of definition I can use for summation for fuzzy if I want to use in data clustering or fuzzy data science. No, we do not have any straight word. I can say that, frankly speaking, say that you need to read all the articles from the beginning, 1987, till now. Try not only read, try to understand. For example, one of the most famous article published by Bede, Professor Bede, published in 2005. So I read it till now more than 56 times. Every time I refer to this article and check my knowledge that regarding this article, find some new thing from it, improve my knowledge. Means that just not only reading, understanding deeply help us to propose some new idea. Otherwise, we will be very, very normal researcher, publishing very, very low impact factor journals, make a very poor resume. And so do not have anything to propose with our colleagues because our background or literature review is poor. This is I am still junior researcher. I'm not very old age, don't have old age. So, but as a researcher with the maybe from 2009 till now that I work on fuzzy, I can advise that if we want to work on fuzzy, at first make our literature review strong, then try to develop new idea for our own work. Otherwise, we will go to the wrong way and reach to the wrong results that not applicable for scientific communities.
Okay, how is it, Mr. Hari?
Okay, thank you very much, Mr. Ali, for the answer and the advice. Okay, Mr. Miss Bhakti Pratiwi, matur suwun.
Okay, since time's up, I would like to make some announcements. The first one is that a recorded version of this webinar will be available in Mathematics official YouTube channel. And then the e-certificate for all participants will be sent by email soon in 2 times 24 hours after this lecture. So please check your inbox or spam. And if you haven't received it until Monday, you can contact Shafitri as the contact person. And then thank you, Dr. Ali Ahmadian. We wish that we can have another collaboration later in the future.
My pleasure.
Thank you very much. And for all participants, thank you for participating in today's webinar. On behalf of the committee, I would like to say sorry if there are any technical problems, and I hope to see you again next time. Okay, goodbye. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Thank you.
Matur
Thank you.
suwun.
Thank you.
Thank you.
Thank you so much.